MacMaths, let's do some maths today. Okay guys, I'm just going to go through very quickly with you the I and J notation and column vectors. So this is representing vectors and it's the second lesson. It's going to be a short one, this one, but I am going to do a supplement to this where I go through some questions because there are some tricky ones that that they throw up in exercise 11b in the pure mathematics AS book. I want to take you back to lesson 1 a second, and we started off lesson 1 where we looked at, I introduced you to two vectors, vector A and vector B, and I talked about this being 1 along and 5 up, and this one being 3 along and 1 up. And we ultimately ended up adding them together, so we talked about A plus B and so on, and B plus A and parallel vectors and so on. But so that we don't have to keep drawing diagrams to solve vector problems, numerically there's a way of doing this, or algebraically if you like as well. Mathematicians do it in two ways. They're really the same way actually. The maths is all the same, but they're just written in a slightly different way. First of all, the I and J notation. So if we look at vector A, in the I and J notation, I is 1 unit in the x direction, the positive x direction. So we have x and we have y, and I is 1 unit in that direction. Okay, so that's what we call I, and J is 1 unit going up in that direction. So that's your I and your J. I should have drawn those separately, so I'll do it on there. J is quite simply 1 unit up. So when we want to describe this as a vector, okay, we can say it's 1 along and 5 up. So we can call this 1I plus 5J. So it's saying 1 right and 5 up, 1I plus 5J. This one, of course, would be 3I plus 1J, which we can just put as 3I plus J. Okay, and that's it. So I and J always look like this. It's always AI plus BJ. So there's always a number there and a number there. Okay. Of course, this could be negative if it's going the other way. So minus I would be 1 in that direction, and minus J 1 down. So it's just like X and Y, but we use I and J. And this allows us then to write what we would call a resultant vector. Now the word is important that you understand this. The word resultant means two vectors added together, or some vectors added together. You'll see that word used. So here we've got A plus B. So A plus B, okay, is this vector here. And now we can describe that because we know that A is I plus 5J, and what we're adding to that is B, which is 3I plus 1J. So A plus B is now I plus 5J plus 3I plus J. That's B. We don't need the diagrams anymore to work out how long this is going across and how many up. We can simply go add the i's together and add the j's together. The resultant of this, the resultant vector, okay, is 4i, adding the i's up, and 5 add on it is 6j. And you can see indeed that this is starting from this point. This is our resultant vector going from there to there, is 1 2 3 4 right, and 1 2 3 4 5 6 up. Okay, so that's the I and J notation. The other way that you've for doing this is you've seen it before. It's just the column vectors. So instead of writing it as I and 5J, they just always put along the X and along the Y, top and bottom, along the corridor and up the stairs. So you must get it the right way around. So I plus 5J, you can either write it like that or write it as 1 over 5, the column vector, and of course this is 3 over 1. Okay, and likewise if you were doing it, adding it up, you'd simply be going 1 over 5 plus 3 over 1. Okay, this is our A and that's our B. Okay, and we add those together, of course. We just add the top, 4, and add the bottom is 6. So 4 over 6. Okay, remember the top is the I, is the along the corridor, as we always do, and the 6 is the up the stairs. So this or 4i plus 6j. Take your pick, okay? But you get questions with both. All right. If we look at this one here, just before I sign off, you can see that this is 2a plus 2b. Okay, so 2a plus 2b, we know that whether we do it in column form or not, we've got, if we just put that there now, you know, we can do 2 lots of 1 over 5 plus 2 lots of 3 over 1. Okay, that's would describe this vector here. If we multiply out by a multiple, and this is 2 over 10, isn't it? That is now, what we've actually found here is 2a. This is what the 2a is, 2 lots of 1 over 5. 1 along and 5 up. Plus 6 over 2, 2 lots of b, and 2 add 6 is 8, 10 add 2 is 12. So 8 over 12, or 8i plus 12j. And from here to here, it is indeed 8 across and 12 up. Of course, we could look at it as 2 times. We'd already worked out the resultant, hadn't we? 4i plus 6j. So 4i plus 6j. And when you see things like that, you can just multiply them out as normal. Okay, just using the Crab's Claw. 2 lots of 4i, 8i, 2 lots of 6j is 12j. Okay, and that's the I and j notation and column vectors. Okay, it's how we describe vectors, and 11b uses both of those methods to present some problems, and in my next video I'm going to go through those, and I hope that is clear. Okay, thank you, over and out.